Okay, so I went back and I looked it up, and this homework assignment was actually homework number 109, which is really great because that means that you're almost done. But I also feel like those notes didn't really help you as much as they should to complete this homework assignment. So I'm just going to help you by doing a couple of those questions out with you for the homework assignment number 109. Alright, so it's in the workbook, page 510, and then I think you had to do numbers 1 through 5, 7, 9, and 11. So I'm going to help you do 1 through 5 probably, or maybe different ones, but we'll see. Alright, so number 1. If you can just grab your book and go along with me. The mean score in a national jump rope competition is 82.75, so your average is 82.75 jumps per minute, and the standard deviation is 2.25. Okay. If the scores were normally distributed, whenever you see the words normally distributed, you're going to draw a normal curve. And what I also did was I got a picture of a normal curve so that mine actually looks good without me drawing a horrible job drawing something. Okay, so normal curve. Which of the following scores would be most likely to occur? So right here, right smack dab down the middle, that's our average. This is 82.75. And then our standard deviation is 2.25. So they're asking which of those scores would be most likely to occur. Now, this is the whole point of the normal curve. A lot of different things in life are represented by the normal curve. We talked about height before, about how a small percentage of the people are really, really short and a small percentage of the people are really, really tall. But the majority of us are about average height. So it's saying which one of these scores is most likely to occur. Now, the part right in the middle, closest to the average, that represents the area where things are most likely to occur. See, because, you know, more area is underneath the curve right there. You know, compared to the areas towards the end where it's tiny little, that means that it's really not very likely to occur. Things that are more likely to occur are the things that are closer to the middle, closer to the average. So we don't even have to like label things on our curve for this question. We just have to look and say which one of these scores is the closest to the average, which one is closest to the middle. So I don't even need to draw my curve to figure that out. If my options are 1, 2, 3, and 4, I can just figure out the distance between that score and my average, and then that'll be it. So my average is an 82.75. The first option is a 90. So what's the distance between those? 90 minus 82.75. That's 7.25. That means it's pretty far away from the average. Option number 2, 87.25. So 87.25 minus 82.75. That has a distance of 4.5 standard deviations away from the mean, or scores from the mean. Option 3 is 80.5, so 82.75 minus 80.5. That's 2.25 away. So far that looks like our best option, but the last one is 77. I don't think that that's going to work. 82.75 minus a 77. That's 5.75 standard deviations away from the mean. Well, not standard deviations. That's that many points away from the mean. So if I were to, you know, graph all these and put the scores in the right places where they actually belong, this one, option number 3, would be the closest to the average, meaning that it's the place where it is the most likely to occur. And I think 80.5 would probably lie right there, because it's actually 2.25 away from the mean, and that's the distance for our standard deviation. So if this is our average at 0 and this is -1, that's 1 standard deviation below the mean, so that's actually exactly where 80.5 would lie. So it is pretty close to the average. It is pretty close to the middle. Alright, so that's number 1. Number 2. The Lite-Brites R.Us company manufactures light bulbs. They advertise that the average light bulb can burn for 1,000 hours. So the average is 1,000. Okay. Tests have shown that this is the mean length of time. Okay, average. The times that the lights can burn are normally distributed. As soon as you see normally distributed, draw a normal curve. Okay. With a standard deviation of 200. 200 hours. What percent of the light bulbs could be expected to last for 600 or fewer hours? What percent of the light bulbs could be expected to last for 600 or fewer hours? Well, let's think about this. This line right down the middle, this represents my average, my X bar. That's 1,000 hours right there. And then it's asking me something about 600 hours or fewer. So am I going to go above 1,000? No, I'm going to go below 1,000. So if this is my -1 or 1 standard deviation below the mean, I would take 1,000 minus 200. That would be approximately 800 hours that the light bulbs last for. That's not at 600 yet. How about 2 standard deviations below the mean? I take 800 and subtract another 200. So that's where 600 hours is. 600 hours lies at the -2 standard deviation, so 2 below the mean. So if you take a look at our reference sheet, and you take a look right here at -2, that's where this is. So it wants to know the percentage of bulbs that could be expected to last 600 hours right here, or fewer. So, or there. So all you have to do is add up all that stuff that's underneath the 200. Add up all the percentages that are under here. So that's 0.6, 0.1, 0.5, that's 0.6, plus 1.7. So 0.6 plus 1.7, that gives us 2.3. That is 2.3%. Because I added up all of the percentages that were underneath the normal curve. The question is asking for the percent, so I added up all the percentages, and that's 2.3% that lasts 600 hours or fewer. So that is choice 2. Okay? Alright. On a standardized test with a normal distribution, as soon as I hear the word normal curve, I'm going to draw a normal curve. Okay. This is number 3. The mean is 85. Right down the middle, right smack in the middle. The score that occurs the most, the average, is an 85. The standard deviation is 5. Okay. If 1,200 total students took the exam, approximately how many of them, how many students are expected to earn scores between 90 and 95? Between 90 and 95. So how many students are expected to score between 90 and 95? Alright, well, first thing what I want to do, I want to figure out where 90 and 95 actually lie on this curve. So you can see that my standard deviation is a 5. So obviously I'm not going to go below the mean, I'm going to go above the mean. So this is 1, 2, and 3 standard deviations above the mean. So this line right here, that's 1 standard deviation above the mean. So we take 85 and we add on another 5, that's at 90. Okay, perfect, because that's the first number that we need. And then we need between 90 and 95, so we're going to add on another 5. That's going to be a 95 right here. Okay, so the question says, how many students are expected to earn scores between 90 and 95? Well, so we're looking at the range in between these two numbers. Like I said before, John, the chart that you have on your reference sheet over here, it's not specific to every single question that we have. It's more of like a general a general diagram to help you out with these kinds of questions. So obviously, if I'm looking between the 1 and the 2, so between the 1 standard deviation and the 2 standard deviation, I could easily add up those percentages, right? Those represent percentages. So that's 9.2 plus 4.4. 9.2 plus 4.4. That's 13.6%. Okay? But that's the percent of students that score within that range. That doesn't mean that 13.6 students scored. That means that it's the percent. So if I have this percentage and I need to actually find out how many students actually scored, I need to find out what 13.6% of the total number of students that I have is. So what is 13.6% of 1,200? Well, how do I figure that out? I take 1,200 total students, and I need to figure out how many students are 13.6%. And if I'm going to write 13.6%, I need to write it as a decimal. So 0.136. And I'm going to multiply those numbers together in my calculator. 1,200 times 0.136. Hit enter. And that is 163.2 students. And you can't have a 0.2 of a student. So your answer is choice 3, which is 163 students. Okay? So you will see questions like that when they want a specific number of people, of students, of scores. And in that case, you need to figure out what the percentage is and then figure out what that percentage is in terms of the total population that you're talking about. Okay? Sometimes your answer, they just want a percent. Sometimes they want an actual number. So you need to be careful about which one they're asking for, okay? Let's do number 4. And then you, I think, could try the rest of the questions by yourself. If the mean of a set of normally distributed data is 14, so right down here in the middle is 14. That's really, really bad. I'm really, really sorry. The mean is 14. And the standard deviation is 1.5. Which of the following data values could be at the 17th percentile? 17th percentile means that I add up all the percentages underneath it, and they add up to be 17%. So the first thing that I need to do is figure out where the 17th percentile actually lies. So I'm going to take those percentages that are underneath my curve, and I'm going to start adding them up until I get to 17. So the first one I'm going to do is 0.1 plus 0.5. That's only at 0.6. We need 17. Plus another 1.7. 1.7. Enter. We're only at 2.3. So plus another 4.4. 6.7. Alright, plus 9.2. That's 15.9. That's pretty close. So you know what? If I add another 15, that's going to be way too high. So I think that right here at the -1, that's as close to 17 as I'm really going to get. So I'm thinking that the 17th percentile is somewhere around 1 standard deviation below the mean right here. It's pretty close. If I had to say anything, I'd say it's a little bit above that because we only hit actual 15.9. So what does that score represent? If this is the average is a 14, what if I take 14 minus 1.5? So that's a 12.5. So I'm looking for a score that's a little bit above 12.5. And I take a look at my answer sheet, and I have a bunch of different answers. 15.6, that doesn't make any sense because that would be up here somewhere. 15.4 would be up here somewhere. 12.6, that is right close to here but a little bit above it. So I think that's our answer, 12.6. And that is choice 3. Alright, so try the rest of that homework questions by yourself and then let me know if you have any questions with it.